1 plus cosine of x equals, I got the cosecant of x minus cotangent of x. All right, Eddie, how'd you do it? What'd you do?
I converted them to cosine and sine.
Okay, so over here on this side, so that gives me 1 over sine of x minus cosine of x over sine of x, and I can write this as 1 minus cosine of x, correct, over sine of x. Am I good there?
Yeah.
And what'd you do?
Well, 1 minus cosine of x is sine of x.
No. All right. 1, and we talked about this the other day. 1 minus cosine squared of x equals sine squared. That is true. And 1 minus sine squared of x equals cosine squared. But 1 minus cosine of x does not equal sine of x. And 1 minus sine of x does not equal cosine of x. Can't do that, okay? Got to be squared. Got to be squared. So right there, you made that algebra mistake, you're done. You know, you're probably never going to recover. So you just got to be careful there. All right, Alex, any ideas from here?
Does the 1 minus cosine of x turn into? Oh, you're.
All right, we're kind of stuck, right? All right, this is where that step 5 comes into play. And it says use conjugates. So if you got a binomial somewhere, you want to try to multiply the top and bottom by that. Now, I'll just start on one side because you say, all right, I got one here and I got one here. Now, yesterday I indicated I'd usually go after the denominator first. So I would make this sine of x over 1 plus cosine of x, and I'm going to multiply that by the conjugate, which is 1 minus cosine of x, 1 minus cosine of x. Now, you got to treat this as in parentheses because you got a FOIL. And I said before, like I'm going to wait to distribute that sine of x in just to see what's happening first. Okay, so sine of x times 1 minus cosine of x over. All right, 1 plus cosine of x times 1 minus sine of cosine. 1 plus cosine times 1 minus cosine is 1 minus cosine squared. Now, 1 minus cosine squared does equal sine squared. So this can be replaced with sine squared. So sine of x times 1 minus cosine of x over sine squared. Okay. All right, you see what I got to do? What's left? I got this sine of x. That's why I wanted to wait to distribute because, and as you do a few, then things start to kind of pop into your mind because I see I have a 1 minus cosine of x. I want this to be a 1 minus cosine of x. If I distribute that sine of x into there, it's going to blow that up. So I'm going to wait. So that cancels with that, and I'm left with 1 minus cosine of x over sine of x. So that's why you always kind of keep, like it says, keep an eye on that other side just to see what's going on. Maybe you can, save a step or two. But that's how you get that one. All right, and then 71, that's a good one. Try and hit that again. See what you can come up with. All right, we are going into section 6.2. We're going to skip this just due to time. We're going to skip that one due to time. All right, sum and difference identities. I'll go over what that means. I just kind of went through everything last night to see where we're at, see where we're heading. We're gonna have one of those little 10-question quizzes Monday, formative. Eventually, we're going to have them summative, just like sine of pi over 2, cosine of 330, one of those. Okay? And we're going to have a quiz over 6.1, 6.2 on Thursday. I know you got the ACT Tuesday and Wednesday. So who's taking it Tuesday? Who's taking it Wednesday? Yeah, it's like half and half. So basically, we'll finish 6-2 Monday in class. We'll review 6-1, 6-2. Whichever day you're here, we'll quiz Thursday. So that's kind of the goal. So we'll see where that goes next week. Because I know I won't see the other one, so we're not going to do anything new. All right, if cosine, this is a symbol, Greek letter alpha, this is the Greek letter beta. If the cosine of alpha plus beta is the same as the cosine equals the cosine alpha times cosine beta minus sine alpha times sine beta, find the exact value for cosine of 75 degrees. All right, here's where we're at. We got the unit circle. You know how to find the cosine of 30 degrees. You know how to find the cosine of 45 degrees. You know how to find the cosine of 90, cosine of 120, using the unit circle. But we now need to come up with other angles we can find the cosine of. Okay? And that's the whole point, the exact value, because we're going to go back to kind of developing this, like pretend you don't have your calculator in front of you, just type it in. So I'm going to tell you that's the formula. So I got to come up with two angles that I know, whose cosine I know that add up to 75. What two angles add up to 75 that we already know their cosine? What's that?
45.
45 and 30. So I'm going to flip it and do the 30 first. So cosine of 30 plus 45, okay, is going to equal the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. Okay? And this is another reason we keep going over those trig quizzes, because you need to know. Now, exact value, that's no decimal. You can't have a decimal. Okay? What's the cosine of 30 degrees? You need to know that. Pi over 6 is 30 degrees in radians, but that's not the cosine of 30 degrees. Cosine of 30 degrees is, you got a 30-degree angle. That's 1/2. That's square root of 3 over 2. So the cosine of 30 degrees is radical 3 over 2. Times, what's the cosine of 45 degrees? Well, that's 45. It's radical 2 over 2. Radical 2 over 2. So that's radical 2 over 2. Minus, what's the sine of 30 degrees? Well, I already got the figures drawn. Sine of 30 degrees is 1/2. What's the sine of 45 degrees? Square root of 2 over 2. Well, square root of 3 times square root of 2. Remember your square root rules. You multiply insides together. So it's square root of 6 over 4 minus, this will be square root of 2 over 4. So that will tell me that the cosine of 75 degrees is square root of 6 minus square root of 2 over 4. And that's the best way I can write it. All right, you got your calculator handy. Go ahead and hit cosine of 75 degrees. See what it gives you. I got to pull mine up here. All right, so cosine 75 degrees. It gives me that decimal, 0.2588190.451. And if I do the square root of 6 minus the square root of 2, and I need to put all, I'm going to hit equals. And if I divide that by 4, you get the same answer. So this is how we find the exact value for cosine of 75 degrees. Now, I know, Eddie, you're asking, how did I know that formula? Right? You're probably like, where'd that come from? Since you asked, okay, or since you thought about it, we'll go over it. Now, in order to go over, you gotta remember a couple things. Okay, sine is an odd function, so sine of negative theta equals negative sine theta. Cosine is an even function. Cosine of a negative angle equals cosine of theta. And then our cofunction relationships. Sine of 90 minus equals cosine, and cosine of 90 minus equals sine. All right. And you're going to want to prove that because you just don't accept things to be true anymore. You're always questioning and asking and wondering why. Correct, Evan?
Yeah.
Good, good. So, I actually got the proof here for you. Oh, you're welcome.
Do we have to do proofs again?
What's that?
Do we have to do proofs again?
That sounds like a good idea.
No.
I didn't even think of that.
I wasn't trying, no.
Do you remember the distance formula between 2 points? All right, I'm just going to give you the overview of this. No, you don't have to memorize this. No, it's not going to be on a test. Okay, this is just for your information. Okay, I'm not that cruel. Although, some of you will want to review this and just for your own knowledge. But do you remember the distance formula between 2 points? Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's going to come up. I'm just going to, like I said, give you the overview because it is somewhat complicated. But this is how we come up with that. This is how we come up with that. So we just said, and we just showed that it worked. Okay, I found the cosine of 75 degrees by using 30 plus 45. I plugged everything in, and I got that value. All right, now, where does it come from? This is one way to go about the proof. And I'm just, like I said, I'm just going to give you a quick overview. From geometry, if you got congruent arcs, you got congruent chords. Chord is AC, which is this length here, and then BD is this length. We're going to find the distance between AC. We're going to find the distance beside BD using the distance formula. Well, this is angle alpha, that's beta. Well, if beta is whatever 20 degrees, this is negative 20 degrees. So what's going to happen now is that this angle and this angle have to be the same. I mean, hopefully that makes sense because, whatever, if that's 30 plus 20, that's 30 plus negative 20, still 50, whatever. So those have to be the same, which means these arcs have to be the same from geometry, which means AC and BD have to be congruent. If this is the unit circle, your coordinates are based upon the cosine and the sine of the angle. So the coordinates at point A is cosine alpha plus beta because that's the angle. Sine alpha plus beta. The coordinates at point B are cosine alpha, sine alpha. Coordinate of point C is 1, 0 because it's the unit circle. And the coordinate of point D, this is a negative angle, is cosine negative beta, sine negative beta. But using what we know over here, the cosine of the negative angle equals the same thing, and the sine of the negative angle equals the opposite. So that becomes cosine beta, negative sine beta. Now, this right here is your distance formula for points A and C. That's for points A and C. This is for points B and D. So I know those lengths are the same, and so I just set that up. Now it's just a bunch of algebra. After that, you go through and you FOIL, okay? Then you combine. And if you notice here, cosine squared plus sine squared, well, cosine squared plus sine squared always equals what? 1. So that whole thing becomes a 1. And now, but in the end, here's what I end up with. Okay, like I said, you got all kind of algebra in there, but in the end, cosine of alpha plus beta is equal to cosine alpha, cosine beta, minus sine alpha, sine beta. Obviously. Okay. You need to know how to use it. I'm not going to make you go through the proof, but it's in your book too, if you want to look it up. Oh, what page? It's in there. Or a form of it. Oh yeah, page 631. Similar. You understand? All right. QED. Wendy, you know what that means, don't you? Oh, you have to ask Holly. Okay. That's abbreviation of a Latin phrase. Well, I don't even know if I can say that. Quod erat demonstratum. Literally, which was to be demonstrated, and figuratively, which means I rest my case. You know, all the big mathematicians put it at the end of their proofs, so you guys can put it at the end of your proofs too. So it's abbreviated form at the end of a mathematical proof to signify that you are done, basically. Who came up with this equation? I don't know. Does it say here? Probably some Greek guy.
You just sit there and do
You gotta understand, way back in the day, they didn't have these little suckers to go from. So that's a good Google. Google it. Who came up with the cosine sum formula? See what it says. See what it says. But you need to be able to use it. Okay. Now, if you have your little identity sheet, we're now on the right-hand side. That's the very top one. Okay. And what we need to do is we need to verify the ones below it. And this is how it works. You can use any formula above it to help prove anything below it or anything to the left. Like everything to the left we've already proven. Okay. I am going to make you prove this one. It is nowhere near as difficult. Once you prove the first one using that difficult method, then it gets a little bit easier. And I'll show you the trick. Anything show up?
Well, I don't know, what was it called again?
The cosine sum formula, I guess. Or you could say maybe even trig sum or difference formulas. Who came up with this trigonometric sum and difference formulas?
It says Muhammad, I don't even know what to say after that.
Oh, Muhammad. What year?
9th century AD.
All right, 9th century. All right, 9th century they were doing this. Okay, I think we can handle it. Okay, back in the 9th century. All right, now when it's alpha plus beta, okay, it's the cosine of the first, cosine of the second, minus sine of the first, sine of the second. But when it is cosine of alpha plus beta, it ends up being, or alpha minus beta ends up being a plus. All right, so now here's what we're going to do to prove it. Now, it doesn't take many steps, about 4. Here's how you have to work a proof. You have to start just with this piece right there. You have to start with that, and then you can use anything above it or anything to the left in it. And then you have to end up with this statement here. You can never use what you're trying to prove inside the proof. That has to be your last statement, your last sentence. Okay? So here's what you're going to do. Here's the proof. I'm going to start with cosine of alpha minus beta. And I'm going to rewrite that as an addition problem. Now remember, And this subtraction is adding the opposite. So remember way back when you learned to do 4 minus 9, you said, oh, that's 4 plus negative 9. So we're going to do the same thing. So cosine of alpha minus beta is cosine of alpha plus negative beta. Okay, we know from this big, long proof what the formula is, for a sum, adding two angles. We know that. Now this isn't part of your proof. I'm just going to put this here, up here. We know that cosine of alpha plus beta is equal to the cosine of the first, cosine alpha, times cosine beta, minus sine alpha, sine beta. Okay? I have two angles that I'm adding, so I can use this formula. Wherever there's an alpha, I'll put in an alpha, but wherever there's a beta, what do I have to put in? I have to put in negative beta. So using this formula and these two angles, this now becomes cosine of alpha times cosine of negative beta minus sine of alpha times sine of negative beta. Okay. Now, if you notice, you don't see a negative beta in there, do you? In that final answer. Can't have it. So we can't have a negative beta. But from what we wrote down here, so the sine of a negative angle is going to be the opposite. The cosine of the negative angle is going to be the same because one cosine is even and sine is odd. So what that means is I'm going to use those facts. Now, this isn't really part of my proof, and you don't necessarily need to write it down unless it helps you. But I'm going to say that the fact that cosine of negative beta is going to be the same as the cosine of beta because it's an even function, and the sine of negative beta is equal to the opposite of the sine of beta. So now this now becomes cosine alpha. Cosine of negative beta is the same as cosine of beta minus sine of alpha. Now do this for me. Sine of negative beta is the opposite of the sine of beta, so put that whole thing in parentheses so it doesn't look like you're subtracting, because we're not subtracting, you're multiplying it times a negative. Well, this becomes minus sine alpha times negative sine beta, so it's really like a negative times a negative, which becomes what? Positive. So this now becomes cosine alpha times cosine beta plus sine alpha sine beta. Is that the formula that we started with or that we wanted to prove? So we're done. And when you're done, you can put down a little QED. So we started with what's on that. Let me see if I can do this. I started with this little piece here on the left and using anything we've already proven. So anything above it on this sheet or to the left, because we've already proven all that, I can use. And so it's really, you have to have 1, 2, 3, 4 steps. You got to have those 4 steps. That's it. Those 4 steps. And what's in red is just things we've already used. It just kind of explains what you're doing. You don't have to write that down as part of your proof. You can, but you don't have to. Okay. All right.
How do you get minus sine of alpha? Because in number 1, it doesn't even have sine up there.
How do you get right here?
Yeah, how do you get from 1 to 2?
Okay, because this right here is I'm adding 2 angles. And using this, we already showed the formula If I have a plus, is I take the cosine of the first, cosine of the second, minus, I use this equation from the first one. Okay, which we proved, well, I don't want to say we, somebody proved it, using that whole thing. Okay, so I don't want to use this whole thing every time, but since I proved that is true, then I can use it once I write that as a plus. Okay. All right, now that's the main thing we're going to do with the proof. Yes, you're going to have to know this. Yes, it will be on the quiz. Okay. But the other two, I'm not going to make you prove it just because of time and just kind of with the ACT and all that. But we could. You could. But that's the next one. And these are right off of your sheet. So these are all your sum and difference formulas. You just got to be able to use them. Now, tangent's a little bit nastier. Okay, tangent's a little bit nastier. But those are all your sum and difference formulas. I'm not going to require you to memorize them all. You will be allowed to use this side of this sheet. Okay, you'll be allowed to use the right-hand side of the sheet. You need to know the left-hand side. All right, now let's go back. Actually do a problem. What's the sine of 195? Do you know that? Do you know that? Let's shoot. Using the unit circle. Is that one of our unit circle angles? No. So we can't figure out the exact value. So we either need to come up with two angles that we know that add up to 195 or subtract to 195. So two unit circle angles. Can anybody come up with those? Just it's people can have different ones before we actually start. Okay.
150 plus 45.
Okay, 150 plus 45. That's an option. Can anybody come up with something that subtracts to it? How about 240 minus 45? And I'm trying to think anything else. 120. We did 45. 135 and what? 135 plus 60 or 60 plus 135. So you can have different combinations. It just depends on what you pick. You got to come up with the same answer. Well, I did 240 minus 45. Okay, just so that we do a difference formula. All right, on your sheet, what is the sign of alpha minus beta? What is the formula for that? Okay, Maria, read it to me.
The sine of alpha minus beta equals sine alpha times cosine beta minus cosine alpha times sine beta.
And sometimes, you can read the alpha and the beta, which is absolutely fine. Sometimes I'll say first and second. So it's the sine of the first, cosine of the second, minus cosine of the first, sine of the second. Either way. Now make sure, this is not plus a negative beta. These are just the angle. That's the 240. That would be the 45. Don't make it negative 45. All right, so now all I do is I take these and I plug in the angle where it goes. So it's going to be the sine of the first times cosine of the second minus cosine of the first, sine of the second. Now you do the math. This is why we do those 10-question trig little quizzes. You got to know what sine of 240 is. You got to know what cosine of 45 degrees. You got to know whether they're positive or negative as well. Okay, so make sure you have those. So, let's see here. I'll just do this over here on the side because 240 would be in quadrant 3. It would have a 60-degree reference angle. And 45 is in quadrant 1, and obviously it has a 45-degree reference angle. Watch your sign. So sine of 240 is going to be negative square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. Minus cosine of 240, which is negative 1/2, times sine of 45 degrees, which is square root of 2 over 2. Now we just need to simplify a little bit. And so it's going to be negative square root of 6 over 4 minus a negative, which is a plus square root of 2 over 4. These are all going to have very similar formats, okay? And now it just depends on how you want to write it. I would normally write probably the positive part first, square root of 2 minus square root of 6 over 4. Okay, so I got that. That would be the answer. If you want to check it, plug that into your calculator, see if it gives you the same thing. Okay, in terms of the decimal, you have to check it with the decimal. Okay, so square, and I'm going to do it this way. I'm going to do second square root of 2 minus square root of 6 divided by 4. Okay, it gives me negative that, and so we said what, the sine of 195? Okay, they're equivalent. Okay, they're equivalent. All right, we got to take a look at one last quick one. You can have it in radians. You can have it in radians. Cosine of pi over 12. Now, a lot of times you'll just convert that to degrees and work that way. That's fine. I'm going to keep it in radians just for the practice because, and I'm going to start with what we already know. Pi over 6, pi over 4, pi over 3. Whoops. Hold on. And pi over 6. I'm going to just give these denominators of 12. So that would be 2 pi over 12. Pi over 4 would be 3 pi over 12. And then this would be 4 pi over 12. So I just got to get a combination. I'm going to have to subtract to get pi over 12. So if you think about it, I could take pi over 4 minus pi over 6 because it is 3 pi over 12 and 2 pi over 12. Or I could do pi over 3 minus pi over 4. It doesn't matter. So I'm going to make this cosine of pi over 4 minus pi over 6. All right, what's the cosine formula? Cosine of alpha minus beta. If you just look on your papers, cosine alpha times cosine beta. I believe it is plus sine of alpha times sine of beta. Just double check me so whether that's a minus or a plus. Is it plus? Or do we know what we're looking at? Is it plus? All right, good. All right, so now this becomes, let me get this, cosine of the first, which is pi over 4, which is 45 degrees, times cosine of pi over 6, plus sine of pi over 4 times sine of pi over 6. Cosine of 45 degrees, radical 2 over 2. Cosine of 30 degrees, square root of 3 over 2. Plus sine of 45 degrees, square root of 2 over 2. Sine of 30 degrees, 1/2. So when I'm done, I get, well, close to done. And I end up with square root of 6 plus square root of 4. No, square root of 2. There we go. End up with that. So those are exact values are all going to look similar. You're going to have either square root of 6, square root of 2, and all over 4. It depends on whether they're positive or negative. All right, for that. Main thing you're responsible for is knowing how to use these formulas. Okay, you do need to know the one proof. Okay, you can hang this other one on your bedroom wall if you want, just to kind of look at, see if you can learn it. All right, but you need to do a little bit of work here. And then we'll finish up 6-2 Monday. And review whichever day you're here. Some of you are here Tuesday, some of you are here Wednesday. Those are your seniors. You get double review. Okay, because you guys don't have the ACT. And then after that, we'll quiz Thursday. Because Friday we don't have class. Because I got to get a COVID shot.